Hello and welcome to my video on the Roland MDX 40A 4-dimensional CNC mill. In this video I will show you how to add and remove work pieces such as this, how to switch the bits for the machine, turning the machine on, initialization, setting your origins, and some of the basic functions of vPanel. So let's get right into it. To turn the machine on, you're going to go back here on the right of the machine. You're going to flip the switch and you'll see that this light here that says power will turn on. Now from here you want to make sure that there are no bits currently in the machine, and you're going to press the green power button and this will start the initialization process, and both the modeling and scanning lights will start flashing as it does so. Now the reason you want to make sure that there are no bits in the machine is that so during this process the bit does not collide with any moving pieces within the machine and breaks the bit or causes damage to the machine. From here, once initialization is finished, you can press this white view button to bring the platform to the front. For this next part, I'll be showing you how to switch bits in the machine. So first what you're going to do is open up the machine, and this right here underneath the spindle is called a collet. The purpose of this is to hold your drill bits. What you're going to do, as you can see, the drill bit goes right in here, and then it has these grooves on either side, so that when the collet goes into the machine and gets tightened, it pinches down and holds the bit in place. And there are different types of collets for different size bits. If you have a bit which requires a bigger collet, you have to switch them out. So first step, you're going to take your collet, you're going to put it into the machine, and you're just going to tighten it in there. Twist on in. Now, you want to make sure that it stays in there tight, but you don't want to overdo it, because if you tighten it too much, the collet will close up and you won't be able to fit a bit into it. Alright, that's good. From here, you're going to take the bit you're putting in and 2 wrenches. First, the bit goes up into the collet, and secondly, you use 1 wrench to hold the collet in place, and the other wrench to hold this part of the spindle in place. Do from here, just pull both of the wrenches together towards each other to tighten it. From here you can see the bit is securely in place. It will not move when pulled. It can twist freely. Now, it's important to note that when you're putting a bit in, you do not want to put the bit too far in or leave too much of it out, so it's sticking out too much. So, this is because when the bit will go over to the tool sensor, which is a process you can start on vPanel to get the measurements of the bit. If it is too far down, the bit will slam directly into the tool sensor, which can cause damage to the machine or the bit. Or if the bit is too short, it will not reach the tool sensor and you will get an error. So it's important to just leave a moderate amount of it out. Not too much, but not too little. From here, if you want to remove the bit, you're going to take both of your wrenches, once again. You're going to hold the collet in place. Then you're going to hold the top part of the spindle, and then from here you're going to push the wrenches against each other. This loosens the collet, and from here you can remove the bit. For this next part of the video, I'm going to show you how to put a workpiece into the machine. Now, this workpiece is about 4 inches wide. Most of the workpieces you are going to use are going to be a bit longer, about 5.5 inches. Now for this, you're going to put it into this chuck here. You're going to put it at an angle, like this. As you can see here, the piece is not flat like this, but sitting inside these grooves. You're going to tighten down making sure to push it against the back so it's nice and tight. Now from here, you're going to take this piece, and you're going to unscrew this black piece, allow it to move freely. And as you can see what I've done here with this piece, I've drawn an X on the end of it to find the center of this edge. This is where this piece is going to seat. So put your workpiece in, tighten it, move this here so that this end goes directly on the center of that X. Make sure to push it tight against it, and then tighten it back down so it cannot move. From here, your piece should be nice and stable, shouldn't move around too much. That's pretty good. If you need to, you can untighten it, push it in a bit more, and retighten it to really make sure it's stable. And then, to take the piece out, just do this in the reverse. Unscrew this part, move it back, unscrew the chuck, and here's your piece. This is the V-Panel program. It is a user interface for interacting with the Roland machine. From here, you can move the spindle left to right, up and down, move the platform forward and back, and adjust the rotation of the A origin. Now what I'm going to show you here is how to set the tool sensor. So you're going to go down to your bottom left and click on Setup. From here, you're going to click right here where it says a location of tool sensor on rotary axis unit. You're going to click on Adjust Location. There will hardly ever be a time when you need to mess with any of these other settings in these two pages. So once you hit Adjust Location, the tool down location is fine. Do not mess with this. You're going to click on Start Sensing. Make sure the cover of the machine is closed. And here, as you can see here, it says remove cuttings from the tool sensor. You make sure the tool sensor is clean, then click Continue. So here is the machine. Take notice of the bit currently in the machine and how far out it pokes down. You don't want it to poke down any farther than this, or else the machine will slam into this tool sensor when it senses, as you'll see here in a moment. With this, it'll be fine, but you will be able to see how if the bit is too long, it will hit this sensor. So what I'm going to do is close the cover, and then going back to V-Panel, I'm going to click on Continue, and you're going to watch the machine sense the tool. There you go, it hovers over the tool sensor, goes down, stops right before, and slowly goes down until it presses the button. It's going to check all four angles. Back to center, forward, and back. Very good. If you look back here at the V-Panel program, you'll see it says the detection operation has finished. Click OK, OK, and OK, and the tool sensor has now been appropriately placed. Other uses of the V-Panel application include moving the spindle, platform, and rotary axis to their origins. From this drop-down menu, you can see we have the machine coordinate system, and now with this, we can tell the machine to move to its various positions. The view position, which I already showed you, which the button on the machine moves it to. The X origin, this will move the spindle to the X origin. Y origin moves the platform forward and back to the Y origin. The Z origin moves the spindle up and down to the Z origin. The XY origin moves the spindle and their platform both to their origin. The A origin moves the rotary axis. And then the rotation center Y moves the spindle above the rotary axis. So if I were to click on X origin, and I'll move you over to the machine. When I click move on the V-Panel application, you will watch the spindle move from the tool sensor to the machine coordinate system, which is the far left. select the A origin. Watch, I'll move the rotary axis out of place. Now if I have it moved to the A origin, we'll move back to place. Let's move to the Y origin. This will affect the platform. And it moves all the way back. Now, it is important to note to be careful when moving these around, because you do not want the bit on the spindle to collide with any of the moving pieces. Also, you can select the user coordinate system to have your own origins. So as you can see here, down here where it says set origin point for the user coordinate system, if I were to go over here, right? Now, watch as I manually move the spindle over to the right, away from the machine coordinate system, over here. I will now set my X origin here by hitting apply. The X origin for the user coordinate system is set here. You may have noticed in the top left where it says X, these have now all zeroed out. If we go back to the machine, I will now move the spindle out of place by moving it far to the right. Now, when I hit move to X origin, as I did earlier, we'll move back to the X origin we set. This is important when you put the workpiece in, as you're going to set your origin to the rightmost, to the right side of the workpiece. Now I'm going to show you a little trick I have for properly setting the Z origin. For many of your cuts, you're going to have to make sure that the Z origin is properly placed. So come down here to the Set Origin Point menu, and make sure that this drop-down menu is on the Z origin, so it says Set Z Origin here, with the Apply button over here. Now, for this we're going to be using these blue buttons to move the spindle up and down into the proper Z position. If you come over here to the machine, you will see that I have put the bit back into place. Now what I'm going to do is slowly move the bit down until it's at about level with this point here, as this is where the center of your workpiece will be. This will always be the center of rotation, which is where you want your Z origin. So I'm going to untighten it and move it over here. Now as you can still see it's quite a bit of ways above the sensor. So I'm going to tighten it back here and slowly move the bit down just a bit more. So you can see there it's a bit far. Move it back up a step. Now it's still a bit above it, as you may be able to see. So if I go back to V panel, I'm going to adjust this setting where it says high speed. This controls how fast the platform spindle and rotary axis move. I'm going to move it down to low speed so I have more control when moving the bit. Oh no. Coming back over here, I'm going to move the spindle just down a bit more. And now, as you can see, it's at the very end of the bit is at about level with the end of this piece. I'll move it up just a tad. And there we go. That is the best place for our Z origin to be for our cuts. So now we're going to go back over to V panel. Now from here, where it says Set Z Origin, we're going to hit Apply. As you can see, the numbers for the Z Origin just zeroed out. Now, if you look over here, no matter how high I move the spindle, when I move it back to the Z origin position, oops, let me close the cover first. Whenever I move it back to the Z origin position, it will move right down to where we set. For this next part of the video, I'm going to show you how to install the detection pin and the detection bar so you can detect the jig. This is how you set your A origin and your Y origin. This isn't something you have to do often, just maybe every now and then if you feel the machine has come out of calibration, but it is important to include anyways. This is the detection bar, and this is the detection pin. The detection pin comes with its own collet, which is a diameter of 6 millimeters. We're going to put the collet into the machine, put the detection pin into the collet, and then insert the detection bar as you would any other workpiece. Once you get this done, you'll run the program on B-panel, and this will set the A origin and the Y origin. As you can see here, the detection bar and the detection pin have both been put into the machine. So we're going to go over to V-panel. And from here, we're going to click on Detect Jig, start sensing, and then hit Continue. You will see here that when the process is started, the detection pin will go over to the tool sensor to get its location. And from here it travels back to the detection bar to start getting all of the correct coordinates. And with that, the process has finished.
In the case of catastrophic and unexpected events.
Additionally, up here there is the emergency stop button. In case of any unplanned collisions with your workpiece and the bit or with the machine itself, you will press this button. It will immediately cut off all power to the machine. From here, you need to push the button back in and twist it to have it pop back out and turn the machine back on. From here, you press the green power button, and this will redo the initialization process as if the machine has just turned on for new. From here, I will show you the complete process of getting the machine ready to cut a workpiece. So first off, as you can see, I already have the bit and the collet in the machine over here. So what I'm going to do is go over to V-panel, and I'm going to start the tool sensor process. As you can see, it's moving over there. Now, I measured before I put it in, and you want to leave about no more than an inch of the bit sticking out from the collet. Any more, and the bit will slam down into the tool sensor. Perfect, now that it's finished that, we're going to move now that Now that we have properly sensed the tool, we are going to get our Z axis. So you're going to open up the machine. Move this back in. And bring this guy closer to the bit, but not below it, so you will not interfere with the machine. Then you're going to slowly lower your bit down. That looks about good. Let's check. Go a bit lower, so I'm going to cut down the speed on B panel and move it down a bit more. That looks good. I'll give it one more tap, and that's good. From there, you go to the Set Origin Point menu and set the Z origin, just like we did earlier. Now, as you can see, even if I move this guy up, the Z origin is set. Cover goes right down to where we set. Next up, you put your workpiece with the center already found. Place one end in the chuck, make sure it's tightened. And then move this other guy over to the center of this workpiece where the X is, and lock it down. From here, you need to set your X origin, so we're going to move the bit further to the left, so it's over the right side of the workpiece. Then we're going to set the X origin right there. You can see with it applied there. Now, if I move it out of the way and move it back to the X origin, it goes right there. Now, during your cuts, you're going to have to switch out bits to get further levels of detail. Every time you switch out a bit, you need to set the Z origin again, and you need to redo the tool sensing process. And with that, you're good to go. This program here is the SRP player. This is where you design the cuts that you will send to the machine. So the very first thing you do is you're going to go to Thingiverse. As you can see here, Thingiverse is a website where you can download STL files. Usually they're used for 3D printing, but we can use the same files to cut with the Roland. So I have downloaded this Tiki statue here. So what you do is you come back to SRP Player and you're going to open this file. As you can see here, I'm looking at STL files. This guy's name is Tiki2. I'm going to open it up. Now if you notice, everything is currently grayed out until this file opens. From here, you can now see that the Tiki is loaded, and we have all of these options here. We can save it. We can switch our view of the object. This is a wireframe view. We can switch how we're moving, either shift around or circle around it. We can magnify on parts of it. You can go back and you can reset the origin. Now you also have these options up here, File, or where you can save as, open various other files, and choose some of your preferences. View gives you all of the same options as this toolbar here. Options is where you add and remove material, remove your tools, search through your tools, and correct cutting parameters. And Help opens the digital book, which is all about how to use the SRP player. From here you can type in keywords such as time, and it'll list the objects. Now these are all of the entries which deal with the timing. So if we want to go to, let's go, cutting methods, go down here to display, and it opens up this menu where you can read all about cutting methods. This will be useful when you don't know what is up with your cut. If you're making the file and it seems wrong, you can open this up to get some help. For this next part of the video, I'm going to show you how to properly measure the flute length and flute diameter on all of your bits. First up, you can see this is the casing for our bit. The name of it is the EMB 250 2F 250L. And this is the bit right here. I'm using one of our large bits, so you will have an easier time seeing what it is I will do. So in addition to this, you will need a set of calipers to properly measure your distance. Make sure they're closed all the way and zeroed properly, and that you are using the correct measurement. For this, we will be using inches. So first off, coming back to the bit, you may notice there that the end of the grooves in the bit is down here where my fingernail is, but when measuring the flute length, you're going to come up here to where this first switch point is. So if we take our calipers and measure from there to the very top of the bit, you will notice that we get a distance of roughly 0.5 inches or half an inch. This is our flute length. From here, you take the bit and measure the longest point widthways with your calipers. Make sure to move the bit around and that you're keeping it straight to get as accurate of a measurement as you can. And from here, you'll see that the flute diameter is 0.25 inches. Now what you're going to do once you've gotten the measurements of your tool, you're going to come over here to Options in the SRP player menu. You're going to click on Add/Remove Tool. So you can see here I've already added two tools. What you're going to do is you're going to hit New. You're going to enter in the name of the tool. This is the name that's on the case here, so we will do EMB-250-2F-250L. From here, you select the bit type. This is a ball end. You can see the tip of it is rounded. And then you can see on this menu what it looks like. We then put in the measurements we got with the calipers here to the program. For flute length, we got half an inch. And then for flute diameter, we got 1/4 of an inch. From here, you're going to click on Register. Now you can see it's here with the tools. Then when leaving, instead of hitting the X or hitting Cancel, you have to hit OK for it to save the tool. Now that that's done, you can see if we go back to Options and go to My Tools, and we scroll all the way down to the bottom, you can see the tool we added is now here. So when measuring your workpiece, you're going to take your calipers, make sure they're zeroed out and in the correct unit. You're going to take your piece, and for most of your cuts, you will be using a square workpiece, but you will be treating it as though it is round, so it is important to get the correct measurements. First off, you'll get the length, like so. This piece is 4.1 inches, or yeah, 4.8 maybe. Ooh. Most of the pieces you will use will be longer than this one, however. Now, the most important part is that when you're putting in the measurements, it will ask for the diameter. The diameter is not this distance, right here where it is 1.13 inches. You need the longest distance in the workpiece, so you need this one here. Make sure I wiggle this around a bit to make sure you're really getting it accurate and finding the longest distance, and it's about 1.48 inches wide. While we are on the subject of workpieces, I'm going to show you how to get a workpiece. So, for the examples, I have been showing you this workpiece, but I have mentioned that it is slightly shorter than what you will normally be using. Now this is a cut-off piece of this precision board, this type of precision board. As you can see, it matches this height. But this height is too short for most of the cuts you're going to be doing. So when you're cutting your precision board, you're going to cut it lengthwise. And because you're going to be using a block workpiece, but using it as though it is a cylindrical workpiece, you want to cut it as wide as this measurement. So from the top of the workpiece to the bottom, it is 1 inch, so you want each piece to be cut about 1 inch in length. If you're using one of these pieces, which is bigger, this is 1 3/4 inches, you're going to want to cut it about that much, so it is a square with each side being 1 3/4 inches long. That way when you put it in the machine, it is as close to a cylindrical workpiece as you can get it. Now when cutting this precision board, you will most likely be using a bandsaw out in the shop. Now here I'm going to show you how to open and save your files. As you can see here, save the changes for Tiki 50%. That is the name of this current file I am working on with this Tiki guy right here. I will save the changes. Now what you'll notice here is this is the Tiki 50% file. You come down here, it is an SRP player files. So any files you make and adjust and then save will be here. Any files you download from Cura, like the original, is here. So you can see here, this is the original Tiki. We'll import the data and open it up. This is the Tiki, and as you can see here, the scale is much bigger at 100%. So what I did to save it is I switched the scale. We'll switch this up to 25%. And hit tab. This changes all of them. Now, when I hit X, it says save changes to tiki2.spj. SPJ are the SRP player files, so when I hit yes, I can change the name. This guy will be Tiki 25%, and then I hit save. From here, the SRP player is closed. If I open it back up, you can see that now when I go to open up any files, I can do STL files, like from Thingiverse with the original Tiki, or I can drop down to our SRP player files and do Tiki 25% or Tiki 50%. I'll open 50% back up. You can see it's here now. I'll hit open, importing the file, and now here is our original guy. Alright, as you can see here, we are now in the SRP player program. So what you can see here is that right now we have the Tiki at 50% of its normal size. So what you can see is that by changing any of these numbers, right, say we want to make it 25% of the original size, you type in here, then hit tab. All of these change because we are keeping the XY ratio, and now the Tiki has become smaller. Now, what you can notice is that, say, I move all these back to 50%. If I turn the keep XYZ ratio off, I can now adjust any size, and it won't change the others. Now, because the Y is 20% while the others are 50, we have a very skinny looking Tiki. For the vast majority of your cuts, you're going to want everything to stay the same, so keep your XY ratio on. From here, you can click on the little purple icon to bring that same manual from earlier up to help you. Now from here, this red line represents the rotary axis on the machine. So as you can see, you can change the Tiki to be facing in any direction on this line. Now, what you want is that this left side of the line is the chuck of the machine, so you want the base of your workpiece at the chuck. So because this Tiki, the bottom is here, we want the bottom on the left. Now the reason you do this is because on some of your other cuts, the top will be weaker. Say you have like a chest piece and this part here is really skinny. You want it on the right side away from the chuck so it's under less pressure and less likely to break. From here you can also rotate the Tiki around the Z axis. 90 degrees, 180 degrees, and 270 degrees. Just for most cuts, keep it at 0. From here, we'll move on to type of milling, step 2. So on step 2, type of milling, again, you have all these purple question marks to bring up the manual if you need help, but you also have these other options. Now, better, as you can see here, clicking better surface finish makes the tool move slower and gives you smoother lines when cutting. Faster cutting time cuts faster but makes the cut look rougher. So because this tiki has so many curved surfaces and we want it to look good, we're going to click on better surface finish. Same thing with this menu. You could choose this if your model has many flat planes, so the machine will cut appropriately to that. But because, again, our tiki is so round, we want to cut a model with many curved surfaces. Now from here, we're going to click on cylindrical workpiece, as cutting a cylindrical workpiece gives you different results than a block workpiece. Now you can use block workpieces and cut them as a cylindrical workpiece, which is what you will do mostly. So you can see here with the block workpiece, it puts supports through the center of the tiki, which isn't what you want. So you'll select cylindrical workpiece even though you will most likely be using a block. Now from here, you will be adding supports to the model. This means that when the piece is cut, instead of the tiki being directly in the wood, you'll get a little support, allowing you to easily remove it. You can go into edit here, and this will allow you to change where the supports are. You can move them up and down, and you can adjust their length. Now, adjusting the length is only necessary if it would affect the cut otherwise. So say this was up here, and we had a big old curve in the tiki, where it would intersect the support. You can move the support back up here and it will function exactly the same as if the function is out here, as if the support is out here. So I'll move both of them back and you can change the perspective of what you're looking at. This looks good. You can also change the support width and the support height. We'll apply these changes, close here, and now we're on to step 3, creating the toolpath. From here, we move on to step 3, creating the toolpath. Now, right now, I'm getting a pop-up menu. You won't be able to see it because of the video recording program I am using, but it says the workpiece size required for cutting exceeds the cutting area. What this means is that the workpiece size you need to cut the tiki, because the tiki is large, we need a workpiece that is at least 6.2 inches long and 1 inch in diameter. So because our tiki is too big, the machine can't support a workpiece of this size. So we will go back to step 1, and we're going to lower our percentages. We'll try 30%. From here, we go back through step 2, back to step 3, and now we are good. We put in the dimensions for our piece. For this, we'll put 5'2". Now, as you can see, these numbers are the minimum length and diameter of your workpiece. You can't have a workpiece that is smaller than either of these numbers or it won't work. So our length is 5.2 for the piece of wood we will use, and our diameter is 1.48 inches. Hit tab, and this is a basic rendering of what the tiki will look like. From here, we're going to create the toolpath. Again, you can't see it, but I have a loading bar right here showing us the processes as it loads through them. Alright, now that the toolpath has been created, we go to preview results, and what we're going to do is we're going to click on preview cutting. This is going to give us a 3D model of what the tiki should look like once we cut it. As you can see here, that was the first process, which I'll explain in a moment. This is the second. So this is a rough 3D rendering of what the tiki should look like once we finish cutting. From here you can switch between showing the model, showing the rendering of the cuts. Now, because the estimated cutting time is so long, what we want to do is go back to step 3, where we have our create our toolpath, and we're going to click on edit. Now, the vast majority of the time it takes for you to create a cut is going to be here. From this menu, this is where you're going to edit basically all of your options for creating it, for creating your cuts. So from here, what you see these blue lines are, this is the path of the bit the machine will take to cut out this piece. Now, first of all, what you're going to do is you're going to click on this plus sign by your first process. This is the first step it'll take when cutting this piece. And you're going to come down to scan lines. Now, all of your cuts will be much faster if instead of doing the axial, as you can show here, you're going to do circumferential cuts. This will cut it similar to a lathe. So instead of going back and forth, the machine will cut around it. From here, you're going to leave the cutting position starting at the right, and you're going, make sure to click apply your changes. Now, cut area. As you can see here, this is the area of the workpiece it will cut. If you choose partial, you can say you want the eyes to have more detail than the rest of the tiki. You can come here and focus on only cutting this part of the piece. For the first roughing process, we want to cut everything, so we click on all. Depth is fine, no need to change that. This changes how deep it will go. The machine automatically does this most times, as long as you set your Z origin, so you won't need to move it. Now here, this is important. This is where it tells us the tool to use for this process. This is where the tools we add in through this option menu, where we select them. So as you can see, this is one of the basic ones we clicked on. For the roughing process, we want to use one of our big bits. So this is the bit we measured earlier and put in. By selecting this one, it will cut down the cutting time for the roughing process significantly. We will click apply, then we'll move on to apply, and we'll move on to cutting parameters. For here, all of this is good. This affects some various options. The spindle is how fast the bit will be spun in the machine. The cutting in amount is how deep the bit will go into the piece of wood. The path interval is how far in between each step it does, and the finish margin is how smooth the piece should be afterwards. And so for most of your because this is a roughing process where we just want to get a rough shape, 8,000 RPMs is enough because we have such a big piece. And we want to up the cutting in amount from 0.04 inches to 0.1 inches. This again will cut down the cutting time. So we click apply there, and that should be good for our roughing process. From here we go to our finishing process. As you can see here, these blue lines are all much closer to the tiki. This is where all of the fine detail comes in. Again, first step, go to scan lines and create a circumferential cut. This will make it much faster. Click on apply, toolpath. So again, I just got a pop-up menu telling me that the toolpath will be deleted. What this means is that because we already rendered a previous toolpath, it will get rid of that as we make the new one. Again, cut area is fine. We want to cut all of it for this cut. Depth is fine. Ball. The tool we want to use for this cut is a step down from the big guy. So we will be using the EMB 125L. This is a 1/8 of an inch bit, and it will get us finer detail. Click apply. Scan lines are good. Then cutting parameters. As you can see, it's already upped the spindle speed from the 8,000 it had for the bigger bit to 9,000. We'll go up one more to 10,000 just to make sure that the bit isn't broken. Because if the spindle speed is too low, with a small bit, the bit will snap when trying to cut through. Now the path interval and finish margin are all good, so we'll click apply. From here, what you're going to do is click on your finishing process and come up here to where it says duplicate the process. This will give us a second finishing process. Now the reason we do this is so we can choose another bit, or 063L, which is 1/16 of an inch big, and this will give us even finer detail in our cuts. Click apply and check your other options. So you can see here, add a margin is good. We want a margin between here and the bit. We don't need to make it sloped for any reason. Cut area looks good. We want all of the tiki to be cut with this level of detail. Depth is fine. We just selected our bit. Now, the scan lines are already circumferential because we've copied from the finishing one process. And now for cutting parameters, we want to up the spindle speed to make sure we don't break this bit when cutting. Now I believe the max speed you can have is 15,000 RPMs. For a bit this size, we won't need quite that much. We'll try 13,000 RPMs. And with this, click apply and close. Now as you can see here, all of these options for our finishing processes are done. We have one roughing process, a finishing process where it gets some finer detail, and then our second finishing process where we get the finest detail. I'm going to change the name of this one to, instead of copy of finishing 1, we'll name it finishing 2. Click apply. Now from here, again, we're going to create the toolpath with our new options. Now again, I have a loading menu up right here. It'll take a while and we'll come back once it's done. Alright, from here the toolpath has been created, so we're going to go to preview results, and we're going to preview the cutting. This is going to make a 3D model of our cut. Now, because we switched from an axial cut to a circumferential cut when we were editing the toolpath, the loading process for previewing the cutting model will take considerably longer. So I'll come back once that's done. With this, the rendering of the cut is now complete. If you go to show model, we can switch back and forth between what it should look like once we cut the workpiece and what our plans look like. From here, now that we have made the file we need to cut, we're going down here to step 5, perform cutting. Now you're going to hit output to file. These will put all the processes out. We will save them to the computer. Then we're going to boot them back up in a different program called vPanel. So once you click output to file, click start cutting, and this menu will pop up. This is reminding you to set the Y and Z axis origin points at the center of rotation and the X axis origin point at the right side of the workpiece, as you can see here. From here you hit next, and now you can see this says roughing 1, which is the name of our first process. I am going to name it Tiki, we'll call him Dash Ted. His name is now Tiki Ted. This is the first process for Tiki Ted. Now I copy this part with my computer, Control C. Now we're going to hit save. The next process will pop up. I Control V, Tiki Ted into the beginning of it. So this is Tiki Ted finishing 1, the second process. Now we have the copy of finishing 1 process. I copy and paste Tiki Ted. And then I delete copy of, and as you can see here, it's telling us that a file already has the same name, so I switch finishing 1 to finishing 2. This shows it's the second step of the finishing process, and I hit save. Now all of these files have been saved to the computer, and we're ready to move on to vPanel. The final step for milling a workpiece with the Roland MDX 48 involves coming back here to the vPanel. Now at this point, your origins should already be set and your first bit should already be in. What you're going to do is you're going to come down here to this cut option. You're going to delete all, whatever current list is on here. Then you're going to add your plans that we made in the SRP player. You come down here to Roland Plans, and then to this Tiki Ted folder where I saved our plans. First I'm going to add our roughing 1 process, which is the first process in our list. And I'm going to go back here, add finishing 1, open, and then add finishing 2. As you can see here, all of these plans are now on the list. I'm going to save the lists. I'll call it Tiki Ted Lists. This will save it here so we can open this list back up whenever we need it. Now, from here, I'm going to select pause at each file. This means that every time it finishes one of these processes, you'll get a pop-up menu asking if you would like to continue. So what happens when we select output is this first pop-up menu pops up. Now this one is asking if you want to continue the roughing 1 process. Now the machine should already be set up for this process by the time you get here, so you're going to select OK. But then when it asks for continuing finishing 1, you're going to hit cancel because you want it to stop once it finishes the roughing process so you can switch out the bits. So hit cancel for finishing 1 and cancel for finishing 2. Now the machine will slowly go through its processes and cut the workpiece. Now once it finishes the roughing 1 process, all of this will stop and we'll go back to cut. Once we go back in there, we'll continue with the same list, but with the first process where it asks us if we would like to continue roughing, we will hit cancel and we will continue with finishing 1. Okay, the first process has finished, so we're going to come back here to cut. As you can see, we have the same list here. Again, we're going to select pause at each file, then we're going to select output. When it asks us if we would like to run the roughing 1 process, we'll hit cancel. Then we'll hit OK for the finishing 1 process after we have switched out the bits and reset the Z origin and the tool sensor. Then we will hit cancel on finishing 2. We will repeat this process once finishing as 1. Again, we will switch out the bit, reset the Z origin, and run finishing 2. With all of our processes having been run on the machine, we have now finished with our cutting and have a successful cut. Now all that's left are some final notes. Firstly, always use protective gear when switching out your bits or opening up the machine, as you do not want any of the dust from the workpiece getting in your eyes. Secondly, we have a vacuum in the shop for cleaning this out in between cuts to make sure everything stays clean. Also, when saving and editing your processes on the computer, always make sure to keep them organized, put them in the same folder, and keep everything easily accessible. Also, it may be good to write down what bits you use for each cut so you can have those processes, so you can know which bits to switch out while they run on the roller. Alright, that's it for this tutorial. With this tutorial complete, you should now be able to confidently cut any type of cut on the Roland MDX.